It is an enormous pleasure to have him here to talk to us today. Ladies and gentlemen, would you give a huge round of applause to Anthony Vanky.
Thank you all so much for having me. It's my pleasure. I've never had such an introduction with so much gravitas in his voice, so I really appreciated that. And I have to say, I was here last year in a smaller capacity, and to see the growth of this digital event from 2014 to 2015 is astounding. It looks, from the outside, at least twice as large. So it is a testament to how hard so many people have worked, the dedication that you all have to this. So you should all feel really good about being part of a really, really cool trend, a really great story here in Wales. So I'm here to talk maybe a little bit differently. You know, there are many panels talking about big data, smart cities, and all of that. But maybe let's take a different look at this trend. And I'm going to do it through the lens of what we do from there, our little corner of MIT. And I would be remiss if I didn't say that I am only one of many people. We're a lab of about 50 people spread over 2 centers, one in Boston on campus and one in Singapore full-time, and one actually popping up soon in Amsterdam. That brings together brilliant people from many disciplines. And I think this is unique. And I think, you know, for me, looking at the future of innovation, I think more of this will happen. If you look at the composition of our room, you know, of our lab, it would be amazing to see people who don't share common languages in that we speak different disciplinary languages. A third of us come from the spatial planning, spatial aspects of architecture, urban planning. A third of us come from the maybe more computational fields of computer science, mathematics, applied physics. And a third of us come from the humane disciplines, looking at anthropology, sociology, legal aspects. And when you take these people with such a breadth of disciplines and shake them up a little bit, hopefully great things come out. And the other side of the recipe are the people that we work with around the world who represent industry. So we work with some of the largest companies in the world, General Electric, the Coca-Cola companies, and governments, from the government of Singapore, the city of Cape Town, Copenhagen, Rio de Janeiro. And these parties together at the same table have the potential to do a lot. We don't have enough kind of hubris to say we can just do it alone at MIT. We really need these partners to scale, to have access to living laboratories to really test new ideas. And what we do is ultimately in service of this, looking at this. What you're looking at, quite literally, is a story of all of us. We call this the signature of humanity, bringing together all of the global telecommunications, all the hellos and goodbyes, the congratulations on the business deal, hey, let's do lunch. What you're looking at is a visualization of all the communications globally over the telecommunications network that's supported by the Ericsson system, which is the backbone to a lot of the telcos that we know and sometimes love. And that's the important aspect, the idea of the signature of humanity, that in a way, all of what we do in this room isn't about the next great app. It's about how do we make lives better. And as I said, we work with cities. And some people, at this event and elsewhere have used the term smart city. Great. We wish we had trademarked it. If we did, we'd have our own building on campus. But smart just lacks something. One of my friends said smart is best described as simplistic, mechanistic, and you can go on with the rest of the words. Automatic, reductivist, tautological, because it doesn't deal with people. The fact that the lights turn on when we leave the room, does anyone really care other than the facilities manager that the lights just turned off when I left? Really, do you honestly care that the lights just turned out? No, you have other things to worry about. And it's not necessarily sensible with an eye in that, is it always the most efficient that you want? When was the last time you went to a city? Because it's efficient. You go to Paris because aspects of it are inefficient. There's a humane aspect with the technology. So that's why we tend to use this word with a funny spelling. That word hates, you always get the little red jaggy. Because it's about the idea that we can sense, but it doesn't always mean that we want the most efficient. Because that's a different way of looking at technology. Many of you know this looking at the technology world, but this is the context. 5 exabytes of data. which is the amount of data that we produced since the dawn of humanity to the year 2003. That's every Gutenberg Bible, every New York Times, every, South Wales Argus, all of that put together in this number. This is also the same amount of data that we produce every day now. So when you look at this data that's coming from all of us talking to each other, from us using our mobile devices connected to the internet, through all these new devices that are connecting to the internet and mediating kind of our experience with technology, and increasingly as machines talk to machines without the need of people, you can really do amazing things. And what we're looking at is, to use kind of a term from the engineering fields, it's a real-time control system. We're looking at both the idea of sensing and actuation. But now with all of these new smart technologies, it's as if that every atom and every brick is becoming a sensor and an actuator, which is changing the way we can experience and use cities altogether. And why cities? Why should you care? Well, for us, we think that cities are the greatest invention that humans have ever created. They're only just 2% of the Earth's crust, a tiny amount, but more than 50% of the world's population, 75% of energy consumption, and 80% of CO2 emissions come from our cities. So a small change on the Earth's crust have major impacts on the future of our species. So that's the polemic side. I'm done. Now we're going to get into the fun part with projects. Many of us have talked about big data, and many of you are dealing with big data, and I could talk about big data all day. But maybe let's take a different look at it, and really let's ask interesting questions. And I think that's where we provide innovation. I was talking to the deputy minister earlier, and I said, we get some of the most brilliant minds applying to our lab and to MIT. And we can teach them almost anything. We can teach them how to program. We can teach them how to put two pieces of metal together. We can do all that. The thing we can't teach is the ability to ask a good question. So not to say that all of what we do are really good questions, but at least hopefully they're interesting to you. So I'll take you to our first project back to 2006, before anyone was using the word big data. And we had a question. Can we draw a map in real time? Geographers and cartographers have been drawing maps for eons since we took stick to sand. But how do you do it how do you do that in real time, looking at the dynamics of the city as it lives and breathes? So we did this apropos to now, since it took the United States to take down FIFA, but also our women are playing in Canada right now in the Women's World Cup. We want to look at the city of Rome during the 2006 World Cup. And how are we going to draw a map in the real time? Well, we're looking at the data that we produce in real time, our telecommunications data. So we worked with Telecom Italia to tell you the story of the day of the final of the 2006 World Cup. You may remember it. It was famous for the Zidane headbutt and the red card. So for the French in the audience, we're sorry. So this is anonymized, geolocated data. And you're actually going to see the pace of life of Rome. So being Italy, they wake up a little bit later than you do here in Britain. But this is life before the match. And when the match begins, you'll actually see the city go quiet. France scores, Italy scores, halftime, people use the washroom, send a quick message, second half begins. End of normal time, first overtime, second overtime, this is getting exciting. The red card from Zidane, and the match ends, Italy wins. You actually see the excitement of the city when they win. Well, the cool part is, you can see that they partied until about 3 o'clock in the morning. But when you think about what you could do with this data, actually the next day is interesting, because that's when the team and the trophy arrive in Rome to meet the prime minister and the people. So you'll see the people right there moving up to the Circo Maximo, the historic festival center right there, to meet the team. Well, for us, the opportunities are, if we know where the people are, and increasingly now we know where the buses are, why is it that if I'm running late, I have to run after the frickin' bus? Why isn't the bus running after me? That's the real possibility of this data. That's the real opportunity of sensing and actuating. So moving to the other side of the world, to Singapore. Well, it's great that we looked at one event. And what can you do with this data? How can you actualize it at kind of the city scale? And people have tried for many years. This, not our project, was the real-time economic control room of the government of Chile, where you had brilliant people sitting in these Star Trek chairs, looking at real-time indicators of the economy coming through the telex, the predecessor of the fax machine, on all these screens, and this one person is supposed to sit in this chair and push those buttons and decide more corn, less oil, more sugar. Suffice it to say, this didn't quite work. If it was, the economy of Chile would be a little bit different. It was just, it's a lot of data for one person to handle. Well, and then, society tried it again in 2012, the real-time control room for the city of Rio de Janeiro, where this poor person sitting in this corner is looking at all of these monitors, deciding where to put traffic police. Would any of you love to be the person in charge of placing the traffic police in a giant city? It's a lot of effort. He has all of these decision support systems helping him, but it's still a lot for one person to decide. So we thought, well, why don't we change the model? Because this little device has more processing power than the US government had to do that. So maybe instead of one person making a decision, maybe a lot of people can make small decisions working towards that efficiency. So to do that, we're pulling together maybe what we call the Internet of the City, that we're pulling together data from public and private sources, putting it together and creating a platform much like these. How these opened up the opportunities for historic data, we're trying to do that with real-time information. So I'll show you a little video of our first pilot in trying to actually open up the Internet of the City, working with public and private to actually make this data available for the first time. So we worked with a variety of partners from across the island. And we want to open the discussion with the general public. So as part of our process, we have something called the urban demo. So many people are worried about getting that app perfect before you share it. Well, sometimes for our work, especially as academics, it's better to get people involved earlier. So we worked with the Singapore Art Museum to create these real-time visualizations to actually start that discussion of the real-time city. So using that telecommunications data, seeing where people are across the island in real time, so you can actually begin to point out the financial center during the business day. Looking at the relationship between energy consumption and the urban heat island effect. So actually, are you making the urban environment warmer because you're using air conditioning in buildings? During special events like a Formula One race, seeing the excitement of the city by mining social media, but also the quantity of telecommunications, to something like, can you find a taxi when it rains? So looking at real-time GPS and availability of taxis and weather data to actually see, is there service where it's raining? The answer is no, you cannot find a taxi when it rains. And using those same GPS probes to redraw the map of Singapore based on time it takes to travel versus distance. So as traffic gets worse, the island grows. Then as a measure of the economy, looking at all the flights in and out through Changi Airport, one of the world's largest airports, but also the shipment of goods in and out of the island. Well, this is all great, and one of the things that we learned from the urban demo is that it took some of the most brilliant minds in the world a really long time to create just one of those visualizations. And if we really talk about the Internet of the City, when we talk about everyone accessing it here, that's not possible. We can't ask your grandmother to code up a visualization. So we then turned our efforts to creating a tool for many to use, which we call the Live Singapore Data Browser, which as a means of access, we reduced down some of the complexity of the information while still keeping some of the fidelity and processing into ways that you can create visualizations, but also accessing this through web applications that you can develop, ones that we develop, but also as standalone applications and API so that you can also create applications on top of this data. If you're a government, it's great that you put out the data, but then when you can actually see that your policies are leading to traffic and increased energy consumption, that becomes really powerful. It's also powerful when a 6-year-old can create an app to tell his or her grandmother that the next bus is coming in 6 minutes. But on top of that, she shouldn't take that next bus in 6 minutes because it's crowded. She should actually wait another 2 minutes on top of that, take the next bus, it's empty, she'll get a seat, and get her to her destination in the same amount of time. That is a sensible city, comfort and efficiency, if she chooses to use that. So we're exploring different ways to experience that. And the first kind of initial API will actually be opening in just a few months. So take a look out. And we're really excited to actually create the first full internet of the city that spans with public and private data. Looking at another set of data, closer to here, but not quite in the aisles yet, looking at Spain. We also have access through one of our collaborations to anonymized financial transaction data, where you can actually see the economy in real time. Well, we want to look at just 1 week. As I said, part of our process is an urban demo. And we want to see what stories could financial data tell. So we looked at a week in the lives of Spaniards, the week leading up to Easter. So what you're seeing on the left is the quantity of spending, and then on the right, a map of where it's happening. Blue is grocery spending, yellow is gas, this kind of pinkish color is fashion, and bars and restaurants in red. And you're seeing kind of the pattern in everyday life. People wake up, people spend money, they have lunch, they party because it's Spain, and then they go to bed. But unlike the Italians, they go to bed at a reasonable hour. And then what you're seeing is this is the pace of everyday life, but the pattern starts changing as you get closer to Easter. So of course, Friday and Thursday, a little bit more spending at bars and restaurants when they go out. But then Saturday, you see people basically going, oh shoot, I'm visiting family tomorrow, we should get some groceries. And then Sunday, not a lot of spending because it's Easter, some spending for gas, but then you see a big spike when people get sick of their families. And then the pace of everyday life returns to normal. But if you think about what the data tells us, and as I said, it's anonymized, we know location of spending, we know stores, we also know point of sales, because the terminals are communicating, they're in physical space. We know the time, we know the user profile, so we know if they're international, domestic. For our data, that's all we know. And then the business type that they're spending at. And with just those degrees of freedom, you can tell amazing stories in this city. And we applied now an urban lens on this investigation. And what the interesting thing is, we found food deserts in Barcelona, areas where you cannot get fresh fruit or vegetables or fresh products. That's amazing. For a culture that is so driven by food, you cannot buy fresh ingredients. And if you're a bank, that becomes powerful, because if you think about lending, you can now say, actually, that might be a great investment, even if that person's credit is a little bit weaker. So we applied that logic and thinking, well, can we begin to look at more of these stories? So this is a dashboard that we created. A lot of people are creating dashboards, but we're trying to put that physical urban lens onto this. And we found interesting findings through this data. For as much as the French love to make fun of Americans, our spending patterns are almost exactly the same. We spend the same amount of money per person on the same things, mostly restaurants, in the same areas of the city at the same times. You could barely tell us apart. So if you're French, stop making fun of us. But then you look at a Chinese person compared to the French and the Americans. They have a different spending pattern. They spend the same amount of money at a different time of year, mostly on clothes, not on restaurants. That's interesting. Well, then the fourth part is you look at the Russians. They spend the same amount of money as the Chinese on the same things, clothes, but in different parts of the city, completely different parts. The Chinese tend to go to the mega malls. The Russians tend to go to smaller stores. Okay, now if you're a bank, how is this important? Well, banks are dying. I mean, today, HSBC threatened they said that they might lay off a sixth of their global workforce. Banks are being threatened. If Google started a bank tomorrow, BBVA is gone. Santander is gone. All of these banks are gone. So can you move from financial services to insights? So they actually created, based on this research, a startup to actually be an insights-based company based on this financial data, to actually make this available, to actually now say to the city, the tourism board, stop targeting, money to the US during these periods. They're not spending money on fashions. You should actually target promotions for food. Restaurants, you can actually make 10% more by having special meal promotions. That is the power of data to really change the way that we experience the city. Data can also tell stories about people in very unique ways. So we're actually going to turn the lens on the UK, on the British Isles. We have a collaboration with BT. We've been working with them many years, and we had a challenge out from 10 Downing as they were rethinking about the redrawing of the constituencies. Conceptually, could you do this based on the natural social networks of people? And when they said social networks, at first they were saying Twitter, and we said, well, actually we could do one better. We have this relationship, especially when our relationships with phones are so intimate. I mean, if I call you, probably we have some connection. And if Cardiff has a connection with Newport or London, does that say something about the society? So actually redrawing the map of Great Britain based on these communications between people. So again, we're not the NSA. This data is anonymized and aggregated at the county level. But finding all of these connections between people draws a different map than we expect. In some ways, those borders between feuding families 1,000 years ago hold true. In other cases, they break down. So we created this algorithm that would actually look at this data and partition it naturally, finding where these divisions are. And this is the map that we found. So actually the interesting thing is that, I know Wales is an independent spirit. You're actually very connected to England versus the Scottish, which are almost wholly disconnected from the rest of the island. So that explains last year, right? Sorry, Wales, sorry for those independent folks. But the cool thing is we can apply this to elsewhere. So we looked at different scales. We went back to Singapore, and you actually can find the residential neighborhoods across the island. You can look at France, where actually the borders hold true. The different provinces actually hold true to the social networks. To even little Belgium, breaking it down. The interesting thing is with our algorithm, we can ask, can you actually figure out X number of divisions? So we want to say, can you draw us 2 divisions between the Flemish and the Walloon? And actually you can, so you can see where you should speak French or not. The exception is actually Brussels. And we think it's because of the second-degree connections. All your friends or your business partners, they tend to do more business regionally, so you see that division there. So we can find these divisions. But we think the power is how do you apply it back to people? So we looked at a data set in New York, completely different project, to try to understand mobility dynamics and mobility opportunities. So we looked at a data set of all the trips that happened in New York. There are 13,000 taxis doing several dozen million trips a year. So it's a big data set. And we know taxis are not always efficient. You have the 3 o'clock, too many taxis, not enough people. The 5 o'clock, too many people, not enough taxis. And then you have JFK Airport, where you have too many people and too many taxis. How that happens, I have no idea. So we want to look at this data. And the amazing thing is how precise that data is. If you look at the top one, you can already see some patterns of the city of New York where pickups and drop-offs. But with the fine-grained detail, you can actually zoom down to the street level and actually see precisely where pickups and drop-offs happen. And this is the pattern. So if you're already a transportation planner, you have a transportation background, you can see New York really needs to work on Brooklyn. It's not a balance. Well, Manhattan is pretty balanced. And those inefficiencies, we ask, could we do better? We want to ask, what is the potential for sharing? Could you actually reduce the amount of traffic by sharing rides? So we created this algorithm in collaboration with the city of New York, and now we're working with several companies like Uber. And we want to see, how does the network change? Could we share? And we asked 2 basic questions of New Yorkers conceptually. 1, are they willing to share their ride with 1 additional party? And number 2, would they be willing to extend their total trip time by 2 minutes? So sharing and 2 minutes. And we found that you can actually reduce the number of rides in New York with those 2 criteria by 40%, 40%. Increase that time to 5 minutes. You can reduce the number of rides by 90%, 90%, because of the density, because of the trips. That is efficiency. That is actually powerful. Particularly when you think that Mayor Bloomberg, the former mayor, spent a lot of political capital trying to put in road congestion pricing and failed, versus maybe rethinking that infrastructure. Well, we know we had a successful project when we got death threats from taxi drivers. We said, hold up, we think there's a business opportunity. Charge each person 75%. You just made an extra 50% in revenue with little additional cost. And I'm getting there in the same amount of time, and I'm saving a lot of money. Well, to help tell the story, as you've seen, we like visualizations. We created this website, hubcab.org, which you can go on and actually pick any 2 points in the city of New York and explore the sharing potential. You can see the pickups and drop-offs. You can see what that sharing potential is. So between Penn Station, the main train station, and CNN's headquarters at Columbus Circle, if people shared under those 2 criteria, New Yorkers would save almost $3.5 million, a million miles traveled, and 422,000 kilograms of CO2. But of course, the data can also tell funny stories, like what happens when you just travel between 2 corners of the same block, that New Yorkers would save $77,000 if they could save more if they just walked it, but yeah, that's why we have an obesity problem in the United States. So for us, of course, mathematicians, we like to ask, okay, what happens when you combine 2 trips? Could you actually do it to K trips? We showed this to the city of New York. They said, that's actually really cool. We're like, yeah, you could have a taxi limousine. It's awesome. They're like, yeah, we got that. It's called the express bus. Now shut up. It's New York, right? So the potential is really amazing when you look at this data in different ways. Well, we also talk about the Internet of Things. And a few years ago, actually in the late aughts, we were talking with Qualcomm. And we were thinking about they're creating a lot of new technologies, a lot of sensors where we could start opening up what is now called the Internet of Things, another word that we wish we trademarked. And they said, how do you talk about the Internet of Things? Because does anyone care that this chair is talking back? And really, no one cares that much. So we went back to MIT. We were like, great workshop, Qualcomm. We have no idea what we talked about. We thought, well, what if it's actually the thing we care the least about that talks back? What's the thing that we throw away? Because it's amazing that we know everything about where this thing came from. Engineers and management specialists have optimized the supply chain where we know where the atoms came from, because we know what mine they came from, we know what geological processes created those minerals. Throw this thing away? No idea. No one knows what happens. No one knows the removal chain. So could information actually tell us what that story is? Because if you actually start caring about the thing you care the least about, that could actually be a really interesting way of looking at the Internet of Things. So we worked at the city of Seattle. First, we developed these little tags. Basically, they're like cell phones. They have a GPS tag. They can't make phone calls, and their batteries last 4 months. We wish we also kind of trademarked the battery technology as well. But with a little MIT ingenuity, we want to see what happens to trash. So what you're seeing is the main processing facility for the city of New York. It's single stream, and it's actually amazing, aside from technology. The most efficient way of sorting trash is actually by humans. Machines can actually get up to about 2/3 of the recyclables back. Humans can get up to 90% back with the machine. So it's actually really amazing how important a role people play in this. So we worked in the city of Seattle, one of the greenest cities in the world, one of the highest rates of recycling. They incinerate for energy, they recycle, they do all of the things right. They even have composting. So first we used our tags, later we hacked a Qualcomm device. We invited 500 people in the city of Seattle to bring us their trash. Everything and anything, from toys to shoes to a bagel to a banana, everything and anything, a representative sample. We tagged it. We asked them to take it home and throw it away as they normally would. We went back to MIT and waited for the data to talk back. So at first, things stayed regionally. Things went to the incineration plant just to the north, local recycling facilities within the Pacific Northwest. Some things going to Canada. Under NAFTA, trash can move between Canada, the United States, and Mexico. It's a policy issue, we'll talk about that. But as time went on, the map kept growing. Literally, no one had ever seen this map before. No one had ever been able to see this. And after a month, things were still trying to find their final resting place, and even after 2 months, things were still moving across the continent. More than 2 months, the last thing finally went to rest. The amazing thing is, we knew what people were throwing away, so we provided a map to everyone of what they threw away. And it's actually, what we discovered was it's all the new things in life that we have. The paper, the plastic water bottle, we know what to do with that. It stays pretty local. But it's actually these things, and batteries, and compact fluorescent bulbs that we don't quite know. So they're looking for the most efficient place to end their lives. And even in some cases, we had 2 printer cartridges. Both end up in Baja California. One traveled the Pacific coast, one traveled to Minneapolis, to Chicago, and then back to the same place. Same objects. The weird thing was that actually, because we knew all of this information, that shorter trajectory was traveling by truck, the larger one went by rail. The larger trajectory had a smaller carbon footprint. So when we talk about efficiencies, that's different. But the most powerful story was one of the mothers. We gave her map, and showed it to her, and she saw that a plastic water bottle that she threw away, just one of these things, didn't end up at the recycling plant. It ended up in the landfill. We don't know why, but for her to see that plastic water bottle, something that was just a matter of convenience, will be there for the next 100,000 years. So she said, just for my daughter and for my grandchildren, I can't do that. Why burden them with something that was just a matter of laziness, And she swore off plastic water bottles. And we think that is actually the most powerful story, the behavioral change, to actually change lives based on this information. And something that has impacts on everything else. From the city and maybe the continent scale to the kind of building scale, we wanted to do another data analysis on energy. We have a big lab, so we look at different things. We looked at a small city, the MIT campus, and we want to see the relationship of energy consumption with the buildings. So first we need to know when people were in buildings. So we did this cool project where we actually looked at the Wi-Fi as a proxy for human activity. Every MIT person practically has a chip in their brain, with these and devices. And the cool thing is, so this is a week. You can actually see the different kind of patterns. And the top one is the rhythm of MIT campus as a whole. It's the whole Wi-Fi network. The second one is actually a classroom, so every hour when there's a lecture, you can see it spiking. And then you see when the really popular class, our intro programming class, around 11 on Tuesday, a big spike. This middle one is a dormitory. So you see that MIT people are generally nocturnal. There's a spike in the evening when we do homework. And then, when we're in class, it's low. It spikes in the evening until about Friday, the pattern breaks down. Saturday, a little mix all day because we're watching Netflix. And then Sunday, you have the oh shit moment at 11. It's like, we have homework due tomorrow. You do homework really quickly, and then you go to bed around 5 o'clock. And the last one is a machine, laboratory, with machines talking. And the thing is that we found that there is actually no relationship between building occupancy and energy consumption. And that's not what you want to hear. You want to think that when you leave, the lights turn off. And actually, the problem is it's not the lights. We're in Boston. It's probably like here, in Wales. It gets a little cold during the winter. And our summers can get a little hot. And you don't always turn up or down the thermostat when you leave the room. And the problem is heating and cooling of our buildings. So we thought, well, why don't we rethink the model? Why don't we rethink heating in buildings? So the problem right now is that if you want to heat this room, you have a big machine in the basement that lights a big fire, that heats up air, shoves molecules of warm air through pipes in hopes that a molecule of warm air touches your skin. Any molecule that doesn't touch your skin is wasted energy. So why don't we just beam energy onto you? So this was a concept called local warming that we actually demoed at MIT that actually will follow you as you walk around and actually provide a beam of heat to you. So this is Matthias, one of the people who worked on the project, being our first lab rat, and tracking him. Well, of course, at MIT, it reminded us of something maybe a little more frightening. So we're looking at different ways, different geometries, and the initial kind of this application, what we're finding is that actually you could reduce energy consumption by 30% by beaming heat. So we've been looking at different things. This was at the Venice Biennale last year, kind of a more mechanical system. We're moving away from mechanical system because it's wasted energy, but it just looks so darn cool. And at the Venice Biennale, you kind of want something flashy. So this was us testing it for the first time at MIT. So this is something we're still working on. And hopefully this is something that will be in building shortly. We're also working on the Flip, local cooling as well, which is great if you're in the Middle East. A beautiful project, really rethinking the internet of kind of the spaces of things. Well, the room can actually play into that. But we want to look at a different scale. We have a long collaboration with the Volkswagen group, and we've looked at different interfaces for what your future car may look like. So one is what happens when your dashboard becomes a screen, to kind of developing personal robots, to actually interface with you in different ways. Well, we thought about it, and we were working with the Audi brand. And what is an Audi? An Audi is a very sexy Volkswagen. It costs $10,000 more, but there's a freaking lot of sex appeal. I mean, look at their ad. The city, goes pale when the car is there. Their commercials, it's driving in the Grand Canyon, the Autobahn. But what is an Audi really in life? It's this. That car right there is an Audi. This is the biggest brand disconnect you could have. You bought a really sexy car and you're stuck in LA traffic. So we wanted to think, well, if you're about emotions, can we quantify the motive aspects of driving? So we created this conceptual index called the Road Frustration Index that pulls together different inputs to calculate how terrible or nice your drive will be. The problem is a 69 rating doesn't mean much if it's not calibrated to what people actually feel. So I'll take you on a test drive with my friend Kale on our very first test drive to calibrate the Road Frustration Index.
It was incredibly stressful. It was the most stressful drive I've ever been on. Nevertheless, I think we have a lot of great content to measure road frustration because I'm certainly frustrated at this point.
So we took poor Kale and strapped him up with a bunch of sensors. So we had in the car a whole suite, which you'll see in a second. And we were doing this to measure real-time frustration. So we had GPS to measure speed location, cameras to measure microbody movements, as well as what's going on outside, skin conductance to measure stress, whereas Audi reminds us, or arousal. And we strapped him in and had him go for a ride. So what you're seeing is true. There is no faking. This was his first drive.
Jesus.
Yeah, the lawyers and the insurance company was not happy about that.
Okay. Stop the car.
So we were just sideswiped, and right now my stress level should be through the roof. We got the information, we'll have to process the data and see where it's really at.
So this is his stress having breakfast, giving a presentation to the lab, an MIT econ class, which is not easy, and then driving.
Shit. Jesus.
And then we, of course, had to see his upper bound of stress. A little bit of humor, nerd humor. Just as a side story, I know I'm getting the yellow light, so just as a side story, we were going to scale this up, and then the MIT risk management folks said, no, you're stopping that project. You are not letting anyone else drive. So unfortunately, we didn't scale it, but that really talks about new opportunities with the Internet of Things, that kind of deeper relationship. Talking about relationships, we were working with the city of Copenhagen, as I said, looking at the future of mobility. And if you're in Copenhagen, this is mobility. This is how you get around. So if you're going to intervene with technology, this is where you should start. And we want to rethink the bicycle. Anyone who is riding a bike in Copenhagen or can ride a bike is. So how do we grow that pool of people? Because sometimes that distance is just too far. There are too many hills. You just don't have the physical capability. So what we want to do is create what we call the Copenhagen Wheel, a hybrid engine for your bike, where it actually gives you a boost when you need it and recaptures energy from braking. A beautiful thing that is actually hit the market. It is actually now available, commercially available, from a startup. We're proud that we're making it in Detroit. Supporting one of these great cities. The cool thing is that in the research side, when we're developing this, is also collecting information about the urban environment. Through your phone, you can actually get routing based on health aspects. So if you're asthmatic, we can actually reroute you to avoid those areas. You can control your wheel through your phone, but it's also creating a real-time map of traffic, of pollution, that's actually useful for planners. So you're feeding this data back to the city that is actually useful for the many, while you also getting kind of an extra little boost. So as I said, this is in the marketplace now, and this is the Copenhagen wheel.
This is the Copenhagen wheel. It turns your ordinary bicycle into a smart electric hybrid by simply replacing your back wheel. Connect it to your smartphone, download the app, and you're ready to go. Bicycles are a great way to move around, yet sometimes distances are too long. Hills can get in the way, and hard journeys to work may leave you covered in sweat. The Copenhagen wheel is here to change all of that. The technology was developed over several years at MIT, together with the city of Copenhagen, one of the world's most innovative places for cycling. Its original inventors licensed the technology and founded Super Pedestrian, the startup where we are now working around the clock to bring the wheel to you. Like the best riding companion, the Copenhagen wheel learns how you pedal and integrates seamlessly with your motion. It captures your energy when you brake or go downhill, and gives you a push when you need it, with 3 to 10 times your regular foot power. It's easy.
That's the amazing
Ride it just
part.
like a normal
3 to 10
bike.
times
As
your
you pedal,
human ability
the motor
magnified.
automatically kicks in
So it
with no
actually
additional
becomes
throttles or
almost magical,
buttons.
that it really does push
All
you
technology
along.
for the
The great thing is that it's also significantly cheaper than any other competitor in that an e-bike, it's significantly lighter. You can put it on any bicycle. It costs a fourth of what it costs versus an e-bike, and is even cheaper than a scooter, a cheap Chinese-made scooter. So this actually has the power to really kind of really move people away from oil dependency to do this. Well, just one last project about what working with, no video, nothing fancy, because we literally just started this. Talking about the Internet of Humans. You know, we've been doing a lot of environmental sensing projects, as you've seen, including the Copenhagen wheel. But we want to look maybe somewhere else, especially when you think about, the aspects of human health. The United States went insane, or at least the news media did, about Ebola. And we had all of 6 cases of Ebola in the United States. We shut down airports. A governor, arrested a person and had her locked in quarantine because of this. But a more troubling issue is actually maybe this, where not only is it that 29 million people, about a tenth of the population of the United States has diabetes, but 8 million people have it undiagnosed. This is a public health disaster. This is big. This has implications on healthcare for all of us. So, maybe we can look at a new data set. There's a new field emerging about your biome, your gut flora, the bacteria that live inside you. It's estimated that there are a lot of microorganisms living in your intestines, which is actually 10 times more cells than you have in the rest of your body that compose you. So there's more bacteria living there, and they live and die based on what's happening with your health. So we want to see, can you actually measure your collective gut, the gut of the neighborhood, as a measure of public health? So we're actually creating sensors to place in our sewers. So we're demoing this and trying this out right now in our own backyard in the city of Cambridge to measure a collective sense of public health through this microflora. And as I said, it's recent. Boston had a very cold and long winter, so that's why we're still in coats, but not the sensors yet. We're having to do it manually. So if any of you love the idea of touching raw sewage, please let me know. We'd love to have you join our lab. But we're creating these sensors to create the first real-time measure of public health. People have mentioned to me, well, there was that Google study or that Twitter study that people go on, to Twitter more and write about the flu, and where the flu is breaking out. Well, actually, there are a lot of false positives because there's another factor. It's called the media. When the media starts going crazy, everyone starts searching about the flu. But can we actually measure that through your gut? So this is really interesting and where the new frontiers of the Internet of Things are. With that, on behalf of all of us, hopefully I could share with you a vision of what a different take on the Internet of the City, Internet of Things, and big data can do, and how they can actually impact the lives of many. So as you carry on your discussions, really think about how you can help society, and how you can really help kind of this big picture of our global society. So thank you very much, and I look forward to talking to you offline. So cheers.